All right, let's dive right in. Today, we're going to school. But our student isn't a person, it's an AI. And the skill we're teaching it is one of the most human things there is, learning how to read between the lines.
So here's something you've probably never really thought about. When you see a sentence like Apple announced a new iPhone, how does your phone know you're talking about the company and not, a piece of fruit? For us, it's totally obvious, but for machine, that's some serious detective work.
And that's exactly what we're going to do. We are taking a brilliant but very literal AI and we're enrolling it in a special program. The goal? To turn it into an AI detective, trained to spot exactly these kinds of clues in any text it comes across. Now, this kind of detective work, it has an official name, Named Entity Recognition, or NAR for short. It's basically the art of teaching a machine to pick out key pieces of information. We're talking people, companies, places, you name it. We're teaching our AI to see the text world in categories. Okay, so let's get into the first part of our AI's school day. The mission, should it choose to accept it, is spotting clues in sentences. Now, our AI student isn't exactly starting from scratch. It's what we call a pre-trained model, something like BERT. That means it already has a massive vocabulary and a pretty good grasp of how language works in general. Think of it like a student who can read perfectly but can't quite analyze a story for its characters or setting. It knows the words, but it doesn't know the who, what, and where, at least not yet. Of course, every student needs a textbook, right? And our AI is no exception. So let's take a look at what it's going to be studying from. The AI's study guide is a dataset called Connell 2003. Just imagine a huge library of news articles where someone has already gone through with a highlighter and marked all the important stuff. It's basically a textbook that comes with a complete answer key in the back, showing the AI exactly what a person, an organization, or a location looks like in the wild. And here's where it gets really interesting, how that answer key is set up. For every single word, there's a specific tag. So you can see for the word European, the tag is B.org. That means it's the beginning of an organization. Then for union, it's I.org, which means it's inside that same organization. Peter gets B.per, the beginning of a person's name. This whole system is called the BIO scheme and is way simpler than it sounds. O just means outside. It's a regular word, not an entity. B flags the beginning of an entity, and I marks any word that's inside it. This is how the AI learns that European Union is a single thing, not just two random words. So our AI has its textbook, it understands the labels. This should be a piece of cake, right? Well, not quite. Every good story needs a little conflict, and ours has a big one, a word-splitting problem. And here is the twist. The AI just doesn't see words the way we do. To be more efficient, it often breaks them down into smaller chunks, what we call subwords. For example, take the word lamb. We see one word. The AI's internal dictionary, its tokenizer, might see it as two pieces, law and ##M. That ## thingy just tells the AI, hey, this part is attached to the piece that came right before it. It's a really smart way to handle a huge vocabulary, but, well, it's about to cause us a major headache. And here's that headache. On the left, you see the AI's view of a sentence, a long, long list of all those little subwords, plus some special tokens. And on the right, that's our answer key, our list of labels. All of a sudden, they don't match up anymore. The lists are different lengths. How can the AI possibly learn if its textbook and its answer key are totally out of sync? This seems like a total deal breaker. But, of course, engineers came up with a really elegant solution. It's all about aligning the answer key. The fix is actually pretty simple in concept. If the AI is going to see the textbook differently, then we just need to create a new answer key that's perfectly customized to its unique point of view. And the process makes a lot of sense. Remember how lamb got split into la and emb? We just take the original label for the whole word, which was O for outside, and we give it to the first piece, la. Then we just give that same label to all the other pieces, like emb. And what about those special tokens? We give them a special ignore label, usually -100. It's basically telling the AI, hey, don't worry about these, they're not going to be on the final exam. And just like that, problem solved. Okay, with our data all lined up and ready to go, our student is finally ready for class. Welcome to the main event, training and final exams. This is where the magic really happens. The AI goes through its custom-made textbook again
and again, processing millions of examples. With each pass, it fine-tunes its own internal logic, learning the super complex patterns that scream, "This is a person," or "That's a company." This is the AI's training montage. All that hard work getting ready for the big test. And the results are in. Our AI detective totally aced the test, scoring a 90.5% F1 score. Now, the F1 score is just a fancy way of measuring how good the AI is at finding all the entities without making a bunch of wrong guesses. And over 90%, that's an A+ in my book. The training was a huge success. So, what happens after graduation? Well, it's time to put our newly minted expert to work. Let's see what the AI detective can do out in the real world. And here it is, the big payoff. You give the AI a sentence it has never, ever seen before, and just watch. Instantly, it flags the European Union as an organization, Brussels as a location, Tim Cook as a person, and Apple Inc. as another organization. It's not just playing a matching game anymore. It's actually understanding context. It's reading. So why does any of this matter to you? Well, this little AI detective is working behind the scenes for you every single day. It's the tech that lets your smart assistant highlight a name in a text message. It's used to automatically sort customer support tickets by the company that sent them. It's what makes advanced search engines so powerful. It is the invisible intelligence that makes our devices just that little bit smarter. So, we've just watched an AI learn to read for context, to find the who, the what, and the where hidden in our own language. That is an incredible leap forward. And it leaves us with one really big question. Now that AI has started to master this very human skill, what's next?